Section 8-9, surface areas and volumes of spheres. Our lesson objectives here are to use models and a formula to find the surface area and volume of a sphere. Our key concepts, which are very similar to when we did circles, but it looks like this. A sphere. A sphere is the set of all points in space equidistant from a given point called the center. Alright. A radius is a segment that has one endpoint at the center and the other endpoint on the sphere. A diameter is a segment passing through the center with endpoints on the sphere. If the center of a circle within the sphere is also the center of the sphere, that circle is known as the great circle. The great circle of the sphere. The circumference of the great circle is also the circumference of the sphere. A great circle divides a sphere into two hemispheres. All right. Now, if we take a look at our diagram here, we can see a representation of a sphere right over here, in which we have the great circle right in the middle. We have the top hemisphere right over here, the bottom hemisphere right down there. The diameter, as you can see, goes from one end of the sphere to the other end of the sphere, and it goes through the center. A radius, which is also the same as in a circle, the radius still half the diameter, but it goes from the center to the circumference, or the outer edge of the sphere in this case. All right. Also, it's making mention of circles, because if I take a plane and I make it go through the circle or through the sphere, the resulting image at that intersection is going to be a circle. Okay? All right, moving on to some other topics, particularly Theorem 816. And Theorem 816 is the surface area of a sphere. The surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere. 4 times. So we're talking about surface area. Surface area equals then 4 times. So it's 4 times pi. And the radius is squared, right? So it's going to be 4 pi r squared. And this formula right here is the one that we use to find the surface area of a sphere. All right? We're going to take a look at how we use this formula and how we can use this later on to find other things. All right. Our first example. Example 1a says, find the surface area of this sphere. Talking about this sphere here on the right. Leave your answer in terms of pi. We talked about this in terms of pi. That means that my answer needs to have pi in it. So we have seen that the formula for surface area of a sphere is defined as 4 pi r squared. Okay, we have that part. So now let's see. Do they give us the radius? They do not give us the radius here, but we know that if they give us the diameter, we know that the radius is the diameter divided by 2. So we plug in that 8 that we have there. So we have, this is going to be 8 divided by 2, which is 4, the units are meters, so my radius is 4 meters. Now that I have that, I can go ahead and plug in that 4 into my formula. So that's what we'll do. 4 pi times 4 squared. Okay, 4 squared is 16. Okay, so we have 4 pi here times 16. So then we multiply here our 4 times 16. 4 times 16 is 64. 64, and the pi remains. So it's 64 pi. We're dealing with surface area. Area still in squared units. So my units are in meters, so it's going to be squared meters. 64 pi squared meters. And there we have that. Okay? That's it for surface area for that sphere. Now let's take a look at the problem that you will do on your own. Part B, find the surface area of a sphere with width d equals 14. Give your answer two ways, in terms of pi, and round it to the nearest square inch. Alright? Have a look at this one. Okay, again, we're using the formula, surface area. I'm going to write over here, surface area equals 4 pi r squared. Alright? They tell us d equals 14, which they're basically telling us the diameter. So d, I'm going to use to find the radius. So radius equals d divided by 2, which is 14 divided by 2, which is 7, and that is 7 inches. Okay, then we take that r and plug it into our equation. We have 4 pi times 7 squared. And 7 squared is 49, so we're going to have 4 pi times 49. And when we multiply those together, we get 196 pi. 196 pi, and the units are in inches. Okay, and this is the surface area in terms of pi. So we have that part done. Now to find out what the surface area is to the nearest square inch, then what we have to do is take that pi and 196 and multiply them together. So we have then, I'm going to put an equal sign over here, so this is going to be 196 times 3.14. Okay, and when we multiply that, we get 615.7522, and it keeps on going over there, and round it up to the nearest square inch. So the nearest square inch is the nearest whole number, so this is going to be 616, and it's going to be, and this needs to be square inches over here, right? And it's going to be square inches over here as well. So there we have two ways to express our surface area: 196 pi square inches and 616 square inches. And there we have that problem right there. Alright, moving on here to a real world connection. Earth's equator is about 24,902 miles. Approximate the surface area of Earth by finding the surface area of a sphere with a circumference of 24,902 miles. Okay, now if we take a look, nowhere in here, not in the diagram or stated, they give us what we need, right? It says to find the surface area, but surface area is going to be 4 pi r squared. I do not have the radius. We do not have the radius. However, they're telling us the circumference. If you remember, circumference is 2 pi r. Okay, so since we know the circumference, I'm going to replace this over here with the 24,902. So 24,902 equals 2 pi r. And when we do this, then we can divide both sides by 2 pi. Divide both sides by 2 pi. And we get that the radius is going to be, simplified and everything, it's going to be 12,451 divided by pi. Alright? Essentially, you actually get this to be 24,902 divided by 2 pi. But when you simplify this, it comes out to be 12,451 divided by pi. That's your radius right over there, okay? Now, we go ahead and plug this into our arc right over there, okay? Now, you could go ahead and approximate this. I particularly do not like approximating just yet because I want to keep my rounding errors to a minimum, okay? So if you start getting approximations here, and since I have pi over here, I have pi on the other side, and I don't want to get my answer too far off. So let's get this here. So we have 4 pi, and the new r is 12,451 divided by pi, and that's going to be quantity squared. Alright, so let's actually clean this up a little bit. I can rewrite this as 4 pi times 12,451 squared divided by pi squared. Now something happens here that this pi gets cancelled with one of these exponents over here. And this cleans up even better to 4 times 12,451 squared over pi. Okay, and when we multiply those, we get this huge number over here, 197,387,017.5. So we get 197,387,017.5, and these are miles, but I'm going to write my units in the final answer because it says, does it say anything about to rounding this to any particular specification like tenths or anything? It does not, but the only thing that I have here is a whole number. So I'm going to go ahead and round this to the nearest whole number. So this will be then approximately equals 197,387,17. Actually, that will be 18 rather. 18. And now my units are in miles, but we're dealing with surface area. So the surface area is going to be units squared, so we're dealing with squared miles. And there we have our answer for this problem. Huge number, and it makes sense because we're dealing with the size of the Earth, so the numbers should be big. Okay? Part B is yours. And it says, find the surface area of a melon with the circumference 18 inches. Round your answer to the nearest 10 square inches. Okay? Give this one some thought. I even gave you the picture of a melon there. Good luck. Okay, so still we're dealing with surface area of a sphere. So the formula has not changed, and the approach is very similar to what we did on the first part. So we have surface area equals 4 pi r squared. Alright, that's surface area. Now we know the circumference is 18 inches, and we know the formula for circumference is 2 pi r. So we know that 2 pi r is going to give me 18. We divide both sides by 2, divide both sides by 2 pi rather. And we get r. r is going to be 9 over pi, and that's 9 over pi inches. All right, and then we take that 9 over pi and plug it into our equation here, and we have 4 pi times 9 over pi quantity squared. We go ahead and carry out the squaring, and we get 4 pi. 9 squared is 81. Pi squared is pi squared. And the same thing that happened on the first problem. This pi gets canceled with one of the pi's in this denominator. So my problem over here becomes 4 times 81 is 324, and still divided by pi, and this comes out to be 103.1324, and goes on like that. But the answer says to the nearest 10 square inches. What this actually means is, can we round this up to a multiple of 10? Can we round this up to a multiple of 10? So 103 is very close to 100. So this will be approximately equal to 100, and this is going to be square inches. Square inches. And that is the approximate surface area of the melon here, that happens to have a radius, or actually a circumference, of 18 inches. All right? Moving on. We have now the Theorem 817, volume of a sphere. And the volume of a sphere is 4/3 the product of pi and the cube of the radius of the sphere. Essentially, volume is, as it says, 4/3, so it's 4 over 3 times pi, radius to the third. And that is the formula for volume of a sphere. And this is what we're going to be using to calculate some of these problems right here, starting with example number 3. And example number 3 asks, find the volume of the sphere. Leave your answer in terms of pi. So we need to have pi in our answer. So let's use the formula right now. We have volume equals 4/3 pi r cubed. And do we have the radius? Actually, they do give us the radius. So all we have to do is plug in the numbers that we have. So we have 4/3 times pi. And the radius is 6. So it's 6 raised to the third power. And we do this. We have 4/3 pi. 6 to the third is 216. And when we multiply all this together, this comes out to be 864 pi divided by 3. This does clean up a little bit more, and this comes out to be 288 pi. And the units are in meters. We're dealing with volume, so it's going to be cubic meters. And that's the answer for this problem, cubic meters. It's very nice and easy when they actually give you the radius, or even if they give you the diameter, it's not that bad. So let's move on to part B, which is yours to do. Let's take a look. Part B, find the volume to the nearest cubic inch of a sphere with a diameter of 60 inches. All right? See if you get the same answer that I do. Okay, so here we have this one. Now we're still going to be using the formula for volume. So it's volume equals 4/3 pi r cubed. I apparently still have issues drawing a good 3. That's the best 3 I've done so far, apparently. All right, so radius, right? They do not give us the radius, but they do give us the diameter. So we have the diameter divided by 2 equals the radius. The diameter is 60, so we have 60 divided by 2 equals r, so 60 divided by 2 is 30, so the radius is 30, so that's exactly what we're going to be using over here. So we plug in all that we have, 4/3 pi times the quantity of 30 raised to the third power. Okay, this comes out to be 4 pi to the third over 27, because 30 to the third is 27,000. And this does clean up a little bit more, so this comes out to be 4 pi times 9,000, and that comes because this 3 right here simplifies that 27,000 and it gives me 9,000. Then we can go ahead and multiply all these numbers to get 113,097.3355 ... Actually gives me precisely that. There's no ... after that. It actually ends at 55. But it says to calculate it to the nearest cubic inch. That means that I need to round this up. So this is going to be approximately 113,097. My units are in inches, so inches cubed, or cubic inches. And this is the surface area of that, actually the volume of the sphere given right here. Okay? Moving on, we have using volume to find surface area. Now, these problems are a little bit longer, but they're not too difficult. Once you actually take it one step at a time, which is what I'm going to try to do, you should be able to do this no problem. Using volume to find surface area. The volume of a sphere is 5,000 cubic meters. What is the surface area of the sphere? Now, here's where it comes interesting. We need to find the surface area. So we know that the surface area of a sphere is going to be 4 pi r squared, right? Do we have the radius anywhere? We do not have the radius. We know the volume though, and we can actually use that. So we know that the volume, the formula for volume equals 4/3 pi r cubed, right? So we have that. Now they gave us the volume, so we can substitute V for 5,000, and we have 5,000 equals 4 divided by 3 pi r cubed. Okay, and from here we need to solve for r. The first thing that I particularly like to do is to get rid of the fractions by multiplying everybody here by 3. When I do that, the left hand side becomes 15,000 because 5,000 times 3 is 15,000. On the right hand side it becomes 4 pi r to the third. We divide both sides here by 4 pi. Divide here by 4 pi. Okay. Now, 4 pi and 4 pi cancels out. So that gives us r to the third, which is 15,000 divided by 4 pi. This actually does clean up. This turns out to be r to the third equals 3750 pi. All right. So now that we have that, we need to do something because this is r to the third. I want to find out what r to the third is. So I take the cube root of both sides. So r is going to be the cube root of 3750 pi. All right. And when I actually do that, this approximates to 10.6078, and I'm using this so I can plug it into now our formula. This is our radius now. Now we can go back to surface area now that I have my radius, and we can put in 4 pi, and we take our 10 point, and notice I haven't rounded all that much. I use 4 significant digits. The more I go, the more precise I will be, specifically if I'm dealing with pi. So it's going to be 10.6078. That's the radius, so it's going to be squared, raised to the second power. And when we multiply all these together, we get that the surface area is going to be 1414.0479, and it keeps on going. And does it say what to round it off to? It does not say what to round it off to, so we're going to go to the nearest whole number. So this is approximately equals to 1414. The units are in meters. Surface area, so it's going to be meters squared. And that's how we solve this problem. All right. Part B. Part B is yours. The volume of a sphere is 4,200 cubic meters. Find the surface area to the nearest tenth. All right. Good luck with this one. So we know that the surface area formula, surface area is 4 pi r squared. All right, that 4 looks almost like a 9. So we have 4 pi r squared. Okay, now again, we do not have a radius. All they gave us is the volume. So we know that volume is 4,200. 4,200, and the formula for volume is going to be 4/3 pi r cubed, right? Again, I go ahead and multiply everybody here by 3, and when I multiply everything here by 3, I get this to be 12,600 equals 4 pi r cubed. Then I go ahead and divide everybody here by 4 pi. By 4 pi. This fraction over here leaves me r cubed. And this 12,600 divided by 4 does clean up to 3,150. 3,150 divided by pi. Okay, then I take the cube root of both sides to get r by itself. So I get r equals the cube root of 3,150 divided by pi, and r is going to be 10.0089. Yes, I could have actually left it at just 10 because I got the 2 zeros, but me being the person that I am, that I like precision, I go ahead and carry 4 significant digits, and then at the final step I'll do the rounding. So now that I know what my radius is, I can go back to my surface area equation, and I take 4 pi. Radius is 10.0089. It's going to be squared. And now that we have that squared, when we do the multiplication here, this turns out to be 1258.8780, but it says to the nearest tenth, so the nearest tenth makes this approximately equals to 1258.99, and is going to be in feet. Well, actually in this case it's going to be in meters, right? So it's going to be meters squared. And there we have that. And that's my answer. Alright, that brings this to the conclusion of this lesson. It also brings to closing Unit 8. If you have any questions about this content, please feel free to send me a line or contact me on Teams, and I'll be more than happy to help you. All right, until next time, stay safe, and I'll talk to you later.